Hello, this is part 2 of Introduction to Probability Theory, wherein we would be looking at the different terms used in probability and try to redefine probability using those terms. Well, if you recollect what probability is, it's basically the chance of the uncertainty that we give for a particular thing to happen or not happen. Well, what are those terms or how do we define probability in more technical way? Probability is basically a measure of the chance that an experimental outcome will occur when an experiment is carried out. Well, we are trying to define two new things, an experiment and an experimental outcome. An experiment basically is any process of observation which has an uncertain outcome. So it does not mean any process, but only those process of which the outcome is not certain about. For example, if you have to throw or drop a stone down to the ground, that cannot become an experiment since the stone is definitely going to land down on earth. So its outcome is certain. And whenever you perform an experiment, you might end up with some outcomes that might be certain or uncertain. And we were focusing only on the uncertain outcomes. So all those possible outcomes that can happen by performing an experiment are called as the experimental outcomes. So here are some examples of the experiment. Tossing a coin. When you toss a coin, are you sure about the outcome? Well, we know that we could end up with a tail or a head. But which of them would happen? That's uncertainty, uncertain outcome, and hence it's an experiment. The same case with rolling a die. When you roll a die, you know that there are possible outcomes 1, 2, 3, 4, 5, or 6, one of the 6 faces. But which one? Well, trying to understand it using a business example, I'm planning to introduce a new product. Now, will that be a hit in the market, or a failure, or a moderate success, or a better success than the competition? Well, those are uncertainties, and hence they are also termed as an experiment. Please remember, the outcome of a random experiment generally remains unknown unless and until the experiment has been performed. So the main criteria to define an experiment is that you may have an understanding of the possible outcomes but are not sure about which of them would happen. Such an experiment is called a random experiment. Now, when you look at these examples, the first one of tossing a coin, there are two outcomes. Rolling a die, there are 6 outcomes. Introducing a new product, many outcomes. So the set or collection of all these outcomes are given a separate name, sample space. Now what's the sample space or the event set? The collection of all the possible outcomes for a given random experiment is called the sample space. So if you look at the example of rolling a die as an experiment, you have 6 different possible outcomes. And when you list all of them, that is called as the sample space. In set theory, we call it as the universal set. We could also define an elementary event or a singular outcome. In this case, we are trying to define only one result of the given experiment. In the sense, only one element of the universal set. So the universal set of rolling a die has 6 possible elements. And now if you have a set which has only one of those elements, then it becomes an outcome. In this example, O is defined as a set with the outcome 1, the face of 1 alone coming up. So that becomes an elementary event. However, we could also define events. Now, what's an event? Event basically is a collection of outcomes in the sense They are a collection of singular elements, but they have something in common or a common characteristic. Now, in the example of rolling a die, if you're looking at getting an even number, there are three different even numbers in the sample space: 2, 4, 6. Or let's say, if you're looking at an odd number, then you have 1, 3, 5. So here we define the event A as getting an even number, which has 2, 4, and 6. The set has three elementary events. These are the simple terms that are normally used with probability theory. We would like to understand them a little more. The sample space. There are different types of sample space. Well, if you recall what the sample space is, it's the set of all outcomes or the universal set for a given experiment. Now, the sample space could be either discrete or continuous. So if the sample space elements are countable, we call them discrete. And if the sample space elements are continuous in the terms that they can be mapped into the real number line with decimals and fractions, they call us continuous variables, and hence the sample space becomes continuous. Now let's take this example of a bank which offers loans to its customers. So the sample space are all those customers who have taken a loan. I would like to classify them as defaulters and non-defaulters, people who do not pay and people who pay up on time. Now you can count how many of them have defaulted, how many of them have not defaulted. You cannot measure it. It's count numbers, and hence, in this case, the sample space is countable. Well, let's take another example of a grocery store where people come up to pay. So there are different ways in which payment could be made, either by cash, debit card, credit card, or check. Now these, again, are discrete because you can count the number of people who make by cash payments, count the numbers by debit cards, count numbers by credit card payments, and how many of them by counting as to check payments. These are also examples of discrete sample space. So when you roll a die, single die, your sample space becomes 1, 2, 3, 4, 5, 6. Is this discrete? Oh yeah, because you can count how many ones, how many twos, or it's just 1, 2, 3. There are nothing between 1 and 2. There is no 1.5 or 2.3, so this is a discrete. Well, how about when you roll two dice? Okay, so when you roll two dice, you get 1 and 1 on top, so minimum number is 2. Sample space starts with 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and at 12. So they are also counted, and here is the list. But it's not always possible to have a count numbers of the sample spaces. Let's look at an example here. It's about an airline company that has classified its employees on basis of gender, on the job classification as to different levels of the job, managers, senior managers, supervisors, etc., and on the basis where it operates, depending on the countries like the major hubs, Dubai, or probably Berlin, etc., and based on their educational levels. Do they hold a diploma, a high diploma, a bachelor's, master's, or even higher? Now, how many different or elements in the sample space? You multiply 2 times 21 times 6 times 4. So there you are, 2, 21, 6, 4. And a total of 1008 possible outcomes. Well, does this make any meaning to you? Depends on how and what you would like to estimate and understand. Because a male manager with home base of Dubai and education of bachelor's would be one particular element of the sample space. So does that convey some meaning? Well, depends on how practical the particular classification is. That determines on the sample space. The other type, as we said, is a continuous variable outcome. Well, let's look at an example of making a call using your mobile phone. You make a call. If you talk, it is recorded for the number of minutes or amount of time that you talk. If you do not talk, it becomes 0. So the length of talk could be taken as a variable of the outcome. Not everybody talks the same amount of time. Somebody talks for a minute and a half, minute and 3/4. So, which means time here is a continuous variable. Time is a continuous variable, and hence the outcomes of the experiment of finding out how much time somebody talks becomes a sample space with continuous variables. The sample space would be defined as the sample space S, the universal set, is all the x's or all the times. X here represents the time of talk, such that x is always greater than or equal to 0. Mathematically, we would be writing as s equal x such that x greater than 0. Well, if you look at a simple understanding of the GPAs of students, will that be continuous or discrete? Well, GPAs could be from 0 to 4, which means somebody could have 1.8, 3.7. That means it's continuous. So mathematically represented as x, that's your GPA, given that it varies between x, the GPA varies between 0 and 4. How do we define an event? Event is basically a subset of the sample space. So let's try to define a few events. A simple event or an elementary event is a single outcome. So when you look at only one element of the sample space, it's a simple event or an elementary event. Events also could be discrete, wherein they are count numbers. So an elementary event example of tossing a balanced coin. So when you toss a coin, what are all the possible outcomes that you could probably expect? Well, in this case, you could get a head or a tail. So the sample space remains only 2 elements, head, tail. Now what's the chance that you would get a head or you would get a tail? Oh, that's, as in common terms, 50-50, right? Okay, that means there's 50% chance that you get a head, 50% chance that you get a tail. Now both these outcomes have equal chances of happening. So these two elementary events are called as equally likely events in the sense both have the same chance of happening, 50%, 50%. Let's take another example. You buy a lottery ticket, and so what's the sample space for winning? So you could either win or you lose. So 2 elements. Now, is this sample space or the outcomes of the sample space, elements of the sample space, equally likely? Oh yeah, you got it right. It's similar to having only 2 outcomes here, like the head and the tail. You either win or you lose. So that's 50% chance you win, 50% chance that you lose. You could also define events which are compound in the sense they include 2 or more simple events. So an example of a sample space of 6 simple events could be defined using compound events such as the event A consists of an elementary event E1 and E2. And another set B consists of 3 elementary events E3, E5, and E6. Now displayed in a Venn diagram, this is set A, E1, E2. This is set B, E3, 5, 6, and E4. Here is an example for you to understand compound events. When I roll 2 dice, what is the chance or the compound event of having a 7? Now the rule here is that the total of the 2 elementary events should result in 7. So how many ways are this possible? Die 1 has face value 1 and die 2 has on the face 6. So 1 plus 6 is 7. Or die 1 has 2 and die 2 has 5. 2 plus 5, 7. So here are a list 1, 6, 2, 5, 3, 4, and they could repeat as the first die having 4, the second die having 3. So now these are 6 simple events which constitute a compound event called having a 7. Let's just revisit the concepts of probability that we started with. So probability is a measure of chance that an experimental outcome will happen, that an experiment is carried out. And we know what an experiment is, and we know what are the outcomes of an experiment. So how do I define it technically? So probability of an event is a number value that gives you a measure of the relative chance that the event would happen. So the probability of an event A is normally denoted by P of A. It should be read as P of A. A is the event, always written in capital letters, and P represents the probability. And since it is a relative measure or a ratio, it always varies from 0 to 1. So P of A lies between 0 and 1. What if PA is equal to 0? Oh well, if probability of A is equal to 0, then it means the event could never happen. And what if it's on the other end equal to 1? Well, if P of A equal to 1, then the event is very certain that it would happen. We would continue with understanding this particular idea more in the next module. However, where do we normally use probability in business? Well, business lives in a lot of uncertainty about what happens in the future. We would like to know what would be the average sales next year. We would like to know if we would have a better sales this year. We would like to know the success of our products in the market. We would like to know how we could decrease a negative future event, and hence we study probability to help us understand how we could probably quantify the uncertainty in the environment. Thank you for watching this video. Please continue with the next module.